So hello, I'm Rahul from the University of Toronto, and this is a collaboration between me, my supervisor from U of T, and with Rubaiat, Habib, Tovi, Grossman, and George Fitzmaurice from Autodesk. And we call this SymbiosisSketch, which is a tool for 3D design sketching. And this is the kind of sketches we create using it. Detailed 3D sketches which coexist with the physical world, so you have designs which incorporate physical objects as well as very detailed and expressive virtual objects which are created using SymbiosisSketch. As you can see in this figure, this attack helicopter is a 3D sketch which is created using our system, and the Captain America figure that you saw earlier is a physical object. So you have designs combining both, and you can see the kind of expression that the artist has been able to put into this design. Okay, so why do we call it SymbiosisSketch? So the word symbiosis refers to relationships between organisms or groups which are beneficial to all the participants. And so we wanted to have a relationship between 2D and 3D sketching paradigms so that they both combine and gel together. And we use this mutually enriching combination to enable precise three-dimensional sketching, such as what we think has never been done before. And so SymbiosisSketch users can draw with confidence, with precision, and they use the tool to create sketches which are very expressive and detailed. Okay, and to enable this, this sort of creations, we introduce concept from two-dimensional sketching to the world of 3D sketches. So when I say 2D sketching, it refers to the kind of sketches that you're all familiar with, drawing on a piece of paper or on a tablet, some sort of physical plane. But 3D sketching, on the other hand, refers to the kind of sketches like this. So you have a person drawing strokes which are unconstrained in the air to directly create a three-dimensional concept. And this intuitive technique provides a lot of exploratory freedom, but it comes with its own shortcomings. So commercial, and I'll talk about those shortcomings. So commercial mid-air sketching software like this is relatively new, but there's been a lot of impressive work in the community exploring three-dimensional sketching, trying to increase the productivity of people, the expressivity, precision, drawing comfort. So there's been different sub-areas of research which have explored 3D sketching like this. For example, the pioneering system called I Love Sketch uses purely tablet-bound 2D interactions to draw constrained 3D curves, which are very useful in design sketching. There's another line of research which has used, for example, looked at haptics to improve precision mid-air so for example, this one which inspired us is called Drawing on Air. And here the authors use a haptic device to simulate forces which keep the user or the artist on track on the curves that he wants to draw. And then there have been numerous gestural systems for improving rapid design iterations in 3D. And a prominent one, I think, is this one called surface drawing, which uses sweep gestures to quickly create surfaces in 3D. And then recently there has been, much advance in VR and AR technology, and the hardware cost has been reducing. And so there's been a lot of recent work in this space as well. And last year, actually, we presented experiments which evaluated the limits of 3D sketching. And the particular focus that we had was on precision in sketching 3D curves. And from that, let's see, why did we want to study that then, and what are we doing now to improve it? So let's look at this 3D sketch, which is drawn using an unconstrained system, directly mid-air strokes to create this. And you can see, I hope you can appreciate that the artist has been able to use this system very beautifully to create this very nice concept. But at the same time, I think there's something which can be potentially missing. So there's a particular art style that this leads to, and this, I think, is a fundamental shortcoming of this drawing technique if you're looking for detail and precision. So let's look at some 2D sketches to understand what's potentially missing here. So if you look at these 2D sketches, again, of architectural drawings, you can see that they have many more small details, very expressive textures and patterns that the artists have been able to draw. And that just makes these sketches much more personalized or much more expressive for the artist. And also, if you notice, you'll see another thing, that there have been a lot of occlusion cues which have been provided by the artist in an obvious way, such that by not drawing what should not be visible. And the 3D artist has tried to do the same by drawing surfaces, like kind of surfaces, by sketching many strokes which lie close to each other. But still, this leads to significant gaps, and the surface perception is not that great as a result. Okay, so I pointed out issues in 3D sketching, but what's so great about them? Why do you still want to study them? So there's many unique advantages of 3D sketches. For example, depth perception and depth depiction in 3D is trivially easy, while in 2D you have to master perspective projections, and even experts are known to not be very good at that in the end. Another thing is that immersion and scale is provided by the VR hardware of the day, and you can draw in large scale, while in 2D you are limited to the paper that you're drawing on. And the third thing is that since you're creating a 3D artifact, rendering is super painless. You just use some rendering engine and you get highlights and shadows and everything for free, while in 2D you have to manually go and draw all these things by yourself. On the other hand, the issues are precision is lacking because positioning in 3D is difficult. As a result, it's difficult to draw small details in 3D sketches. And finally, since you have to position many curves in the air, it can be tiring and cumbersome over long periods of time. And if you look at 2D sketching, it's kind of the opposite. For all these shortcomings, 2D sketching has the power to overcome all these shortcomings. That is, 2D sketching kind of provides these complementary benefits that 3D sketches can utilize. And so that was our main motivation behind this paper. Okay, so let's see how we do this. So in SymbiosisSketch, we have a user who has a drawing tablet and an augmented reality headset. And we use this to sketch, and he has a pen in his hand, and the same pen is used to draw on the tablet as well as in the air. So this is a Surface tablet and a Surface pen. So drawing on the tablet is natively supported by the hardware, but drawing in the air, we achieve it using motion capture markers. And note that the sketches that the users created all three-dimensional objects. So specifically, if the user creates a stroke, it's always a 3D stroke positioned in the space around him. And this is important because we wanted to create designs in which you incorporate physical objects in the real world around the user, right? But there's obviously a disconnect. You're drawing on the tablet. How do those strokes translate into 3D curves? That is, if you take these two-dimensional strokes, how do you map them to the 3D world around the user? Okay, so let's see how we do that. So here's this user who's wearing a head-mounted display. Then imagine there's a virtual surface in the air, which we call the drawing canvas. And I'll tell you later how these surfaces are created, but for now, let's assume there exists a surface like this. And the user is ready to draw on his tablet. And now imagine there's a virtual camera in the air, and the camera has this image plane, this rectangle. All cameras have an image plane. So we establish an indirect mapping between the tablet and this virtual camera. So the idea is that it's the mapping which is indirect. That is, the tablet does not need to be co-located with this virtual camera, so the user can keep the tablet wherever it's comfortable to draw. And then if you draw on this tablet, you have your strokes being projected onto these canvases. Okay, so let's see how this looks like. So here we have a user using this canvas. And these are very useful for creating details in your drawing, non-planar details especially, and you can see this in action. And the user gets immediate feedback in 3D at the same time as he's drawing on the tablet. And an additional thing that the users can do is they can toggle a fill option. So this is option that they have. And when this thing is selected, any closed stroke which is drawn by the user, it gets converted into that stroke being filled. So you get this solid surface, which provides you all the perception of occlusion, shading, and all the other rendering artifacts such as shadows. And you saw it in the previous example, but let's see in more detail here. So this Flintstones house consists of a large number of such solid surfaces, and now you can see the shadows and the occlusion that the surface provide. And this is something that just curves lying in the air cannot do. So if you remember the example I showed you earlier from a purely 3D sketching system, I hope you can appreciate the change in the stroke precision and the improved surface perception that our system offers compared to unconstrained sketches. Okay, so the next obvious question is, I told you earlier that you have magically existing canvases, but how do you actually create these canvases using our system? So drawing, we start with this planar drawing canvas because planar curves are very important in design sketches, even if you're drawing in 3D. So the user starts with this rectangular patch in the air, which is the same aspect ratio as his tablet, so he can draw on the tablet and see these strokes in the air. And he can also manipulate this this patch using direct interaction. So if the user brings his pen close to the patch in 3D, then you can see these controls for translation, rotation, and uniform scaling. So you can change what this planar canvas is. And the curved canvas, that's the other type of canvas that you saw earlier, we designed a new, very simple, but I think intuitive interaction to do this. So what the user does is he simply draws a few curves in the air, and then the system automatically fits a surface patch to it. So the user kind of defines the general shape of the surface, and now the surface serves as the non-planar drawing canvas. So if you look at this example, this is a detailed model which was created using our system. So you have strokes which are anchored onto both planar and curved drawing canvases. So here the toy robot is actually a physical object, and all these ancient wings are something we built using our system. And I hope you can see that the details in this sketch are very atypical of current 3D sketching systems. For example, what I showed earlier. Okay, so these drawing canvases allow us to balance between the ease of depth depiction of 3D sketching and the precision and detail that 2D sketching offers. But recall that there's another big advantage of 3D sketches is the sense of scale. So you're interacting with the physical world. You can draw in a 1:1 scale for objects which exist with the physical world. But drawing very large or very small strokes in 3D can be challenging. For example, let's say you want to draw a car in your garage. So there's a sense of 1:1 scale provided by the garage and the size of the car you want to draw. And you want your car, let's say, to look like this, right? But you don't want to draw these really large strokes and move around the whole of the garage just to reach your target positions, right? So obviously there's a need for scaling and translating the workspace. So we start with a canonical workspace, which is in front of the artist, which is reasonably sized, 1 meter cube. It's accessible without moving around too much. So the artist, if he wants to draw at this reasonable spot, which is close to him, he can just draw. But otherwise, if he wants to draw somewhere far away, so he can define a workspace which is arbitrarily positioned, arbitrarily sized, and then there's a mapping between these two. So if you draw a stroke here, it gets mapped to the other workspace. And now you can use these workspaces to get like a zoom in and zoom out effect. For example, if you're drawing the big shape of the car, you can zoom out and draw it in a comfortably sized workspace. But if you're drawing small details, you can do this as well by zooming into the things. And these workspaces are visceral, so you can change and manage different workspaces. You don't just exist with one scaling factor or translation. And there can be many ways of defining this kind of a workspace. So we wanted a method which is efficient, but also helps a user visualize the workspace with respect to the real world. So we start, when the user presses a button, he sees two rays, one from his head and one from the pen. So he can manipulate by moving his hands and his head. And if you coarsely intersect these two, you can define a 3D point. And when you define two such 3D points, that defines the diagonal of a workspace, and that's how you define the size and the position of the workspace that you're working with. Okay, and the last question we tried to answer is that how do you leverage modern AR technology to interact with physical objects for design drawing? So what I mean by this is that using the HoloLens, you get a 3D mesh which represents the world around you. So what can we do with it? So unfortunately, with current technology, the mesh is not that accurate that you can get very small objects or small details, but what you can detect is large physical planes in the world around you. For example, ceiling, wall, tables, etc. And now imagine you can use it to, for example, create a window which is exactly on a wall, create a chair which lies on the floor, create a car which lies on the floor, or create some lampshade which lies on the table, for example. And we do this by allowing users to snap canvases onto the planes which are detected by the HoloLens. And of course, if you use workspace scaling, you can bring this whole room to visualize it at the comfort of your desk. And there's an example. So this fan is pretty large and is mounted on the two walls in this room. And we use this interaction that I just talked about to design it in the large scale, but also small details like the Kai logo on the front of the fan. Okay, and then we try to evaluate our system using 6 professional artists with different artistic backgrounds. So we started with some fixed drawings, comparing between unconstrained drawings and constrained drawing, like we provide. And then we asked them to just freely explore the system, whatever they wanted to do with it, before we presenting them with a standard questionnaire. And I'll give you some feedback, present you with some feedback that we got. So one participant, for example, remarked that the SymbiosisSketch system gave them the sort of control they're used to in traditional drawing, but maybe more importantly, it also brought 3D sketching closer to the enjoyment they felt while drawing in 2D. And another one talked about how they were able to utilize the curved surfaces to easily draw non-planar details in their creations. People also liked the ability to snap drawing canvases on physical objects. But there were some lessons to be learned, some things to improve in the future. So for example, participants still thought that 3D drawing requires much more advanced planning as compared to traditional two-dimensional sketches. But I think overall, the participants were able to successfully use the system. So here's, for example, a result from one of the participants. You can see the paper for other sketches that they created. And the last result I want to show you is a drawing of this Montreal Olympic Stadium next to physical models of building from Chicago. And ours is the first tool which lets you put Canadian buildings next to American ones instantly. You can see that creating such an object would be very painful using only 2D sketches or only 3D sketches. So for example, mid-air strokes allow us to easily draw these suspension cables. Using 3D strokes to define surfaces, you can draw these organic forms and surfaces which are difficult in 2D drawing. And drawing all these small details and patterns would be extremely difficult or near impossible using unconstrained 3D sketches. Okay, so what's next? I think the future is bright. There's much more to be explored in this area. And I feel hybrid interfaces such as ours can really boost the utility of the 3D sketching domain for artists and designers. And in that vein, I encourage you to attend the presentation of a related paper, which is in the next session. And they explore a hybrid 3D sketching interface using 3D hand gestures and pen-based 2D sketching. And with that, I would end my presentation. Thank you very much for listening.
Hi, thank you. That was a really interesting talk. So I'm just wondering, within your system, how you deal with things which are not entirely 2D or 3D, for example, texture or material.
So it's primarily a stroke-based system. So if you want to draw a texture, we don't have any copy-paste kind of thing. So you'll just draw many strokes, such as what 2D artists would usually do. But you can now do it in 3D in a constrained fashion on non-planar surfaces as well, if you want.
I see. Thank you.
Okay.
Hemant from University of Waterloo.
Hey.
I just have one question. So once this 2D plane is selected in 3D environment, do you feel there are any constraints around drawing shapes like disk, which would in 2D plane would look like a single line, but essentially what the effect that you want is a circular disk. From camera's perspective, it is only sort of like dimensionally restricted.
Yeah, so we only work with these like sort of open surface patches, which are always projectable. And the camera that you see that I showed you is not something you can manipulate by yourself.
Okay.
You basically select the surface, and the camera gives you this best projection that you can get, or the most sketchable projection.
Okay.
So you can always draw what you want, but if you want to draw a ring, the camera will be positioned like this. So drawing a line will lead to a line. I don't know if that makes it clear. But the camera is, you can think of the camera as always being in front of the surface.
Okay.
Right?
Yeah.
You can't have a closed surface in the
okay.
system. It's all open surfaces.
Yeah, so in order to draw a ring, then I would probably select a plane which is sort of like aligned with camera, or like orthogonal to camera view.
Yeah.
And then draw a disk from top.
Yeah, and that'll be
Okay.
automatically
Yeah.
selected. We don't have an interaction to actually manipulate the camera
yeah.
independently.
Okay, okay. Thanks.
I'm actually going to ask a question.
Okay.
So you had a number of places in which you had surfaces that were close to each other but not quite meeting. And of course, there's a style in which you really want to do that, but there are other styles in which you don't want to do that.
Yeah.
So I'm thinking in terms of chamfers and fillets and other sort of more caddish kinds of concepts. Do you have any support for that?
No, we did not explore any sort of semantic understanding of the sketches, which you probably would need to do. I mean, one way you could think of is just do purely geometric things, but I don't think they'll work very well. And we did not really explore anything semantic, which would lead to a more intelligent system, which is able to, for example, snap strokes onto something so that you get this feedback.
Okay, thank you very much.